Part A. Find the speed of the particle at time t equals 3. Find the acceleration vector of the particle at time t equals 3. So for the first part, find the speed of the particle at time equals 3, you're going to use the equation speed equals square root of, can't even read that, of x prime squared plus y prime squared. So we're going to need at time t equals 3. So we'll go ahead and plug in our points. So the square root of x prime at 3 squared plus y prime at 0.3 squared. Whole quantity square root. Then we're going to plug that into our equations, going back to our original question, dx dt. So x prime equals 4t plus 1, and y prime equals sine t squared. So I'm going to plug 3 into this value, plug it in here, and then take y prime, plug in 3 for t, plug it in here, and take square of both. And plug that in your calculator, and you'll get a final answer of either 13.006 or 13.007. That was the first part. And then the second part, find the acceleration vector of the particle at time t equals 3. What you need for the acceleration is the double prime of x at 3 and y double prime at 3. And so going back to our original y primes and x prime, take the derivative of x prime to get x double prime, which will give you 4, and y double prime, which will give you 2t cosine t squared. Then plug in these values, so you're going to get 4, and then you're going to plug in 3 to this mumbo jumbo using your calculator. You will get negative 5.466. Part B. Find the slope of the line tangent to the path of the particle at time t equals 3. So for this part, what it's asking you to do is find a tangent line to the original equation. For this, you will need to know dy dx. However, in this problem, they've only given you dy dt being sine 2 squared, sine t squared, and dx dt dx as 4t plus 1. So to get dy dx, you need to take dy and put that right here, and dx right here, which will give you sine of t squared over 4t plus 1. And because they're asking for it, time t equals 3, you plug in 3 here, you plug in 3 here, and using your calculator, this will yield a value of 0.031 or a value of 0.032. Part C. Find the position of the particle at time t equals 3. So, for this, we are trying to find the position of the particle time t equals 3, which will look, as a final answer, will look like this. X of 3, y at 3, because we are in vector. So, for position, you need to integrate the velocity, because integrating the velocity will get you the position. If you integrate it from your initial time, 0, to your target time of 3, for either x and y. So, that's what we're going to do. So we're going to first start by integrating dx dt dt. This will give us x at 3 minus x minus x at 0. So we already know the value at x of 0 because in the problem it gave us the initial condition x at 0 equals 0. So we can go ahead and just plug that right in right here as 0 and gone. So the integral from 0 to 3 of dx dt dt will give us the value of x at 3. So use your calculator with using the function that was given. That will give us 21. Go ahead and save this over here. 21. Now for y, we're going to use the same exact process. Integral from 0 to 3 dy dt dt equals y at 3 minus y at 0. Using our initial condition, y of 0 equals negative 4. I'll plug that in here, plus 4. So now we're going to solve for y of 3 because that is the position that we want. So subtract over 4 and we will get negative 4 plus the integral from 0 to 3 dy dt dt equals y at 3. Using your calculator, that will yield a value of negative 3.226. So, negative 3.226. And we are done. Part D. Find the total distance traveled by the particle over the time interval of 0 less than or equal to t, t less than or equal to 3. So, very simple problem, just finding distance with vectors. So, using our distance equation of the integral from a to b, square root of dx dt squared plus dy dt squared. That's all that it is. So plug in our numbers, we're going from 0 to 3, and I'm not going to write out our functions. So go ahead and plug in your function. Actually, I'll do it. So 4t plus 1 squared plus sine t squared whole quantity squared. Oh, that's not right. Erase. Parentheses squared. That. So plug that straight into your calculator and you'll get 21.0 9, 1. The key to this problem is to know the distance equation. Know it.